One elegant example has been discovered in these giant green slugs from Vancouver. The slugs feed on vegetation and spend their lives silently gliding over the dead wood and rotting leaves which litter the forest floor. What is so remarkable is not the slugs themselves, but the mucus they produce, the gooey slime trails they leave behind them as they move. At the University of British Columbia, Mark Denny.
When most people first look at slime, they think it's the most repulsive stuff they've ever seen. They wouldn't be caught dead working on it. However, if you can get past that initial impression and start looking at it, it turns out to be really nifty stuff.
Mucus sticks slugs to the surface on which they're sitting. What puzzled Mark Denny was how they could walk on a substance that was essentially glue. He decided to look at its mechanical properties. That meant first persuading a slug to let him have some experimental material. The mucus is placed in a test rig. Here it is possible to measure the force needed to shear it, make the molecules inside it slide past one another. The drum is lowered to gently squeeze the mucus, and the machinery is turned on. The results were intriguing. The mucus, it appeared, could switch back and forth between two quite different forms of behavior.
The first thing these experiments show is that when you start to pull on the material, that it acts like a solid. It pushes back at you pretty hard. It takes a lot of force to deform the material. However, once you've deformed it a certain extent, the material abruptly gives way. It yields into a viscous liquid. The important thing about that is that a viscous liquid is easier to move over than a solid would be. The second important thing about these experiments is that once you stop pulling on the viscous liquid, that within a very short period of time, the material can set back up into being a solid. So it's a reversible sort of thing.
Slugs are pushed along by these muscular waves. Mucus beneath each wave is liquid, and so lubricates the path. It becomes solid and sticky again once the wave passes by. This happens because networks of molecules inside the mucus are pulled apart and then spring together again.
To me, the primary niftiness is that you take something that's 98% water, it's almost totally water, throw in a little bit of this very special sort of molecule, and you end up with a material that has these really special properties, the physical properties that suit it to its function in the slug.